Welcome. We're doing the section 2.5 for Math 60, translating phrases into mathematical expressions. So just like we did last class with the percentage and stuff, we're going to go over exactly the words that are often used that we can transcribe into mathematical sentences. First off, for addition, you can see we have an entire list. Sum, the sum of, add, in addition, more than, increased, increased by, plus, total, added to, in excess of, and greater. Subtraction, there's another list. So we're going to be using all of these words and translating them into mathematical sentences. This is the first part of how we deal with word problems. Okay, translate the following statements. A number added to 5. Here's our example. It's either x plus 5 or 5 plus x. I would prefer this answer. A number, right? A number added to 5. That's why I would prefer that number. A number decreased by 7. A number increased by 13. 5 times a number. Obviously, a number is my variable. You can do whatever you want. A number multiplied by 3. N times 3 is fine. You can also write 3n. Either one would be fine. Twice a number, 2n. Triple a number, 3n. Same thing. 3 times your variable. All right. Sum and difference, product and quotient of. Now remember, quotient is division, product is multiplication. The sum of a number and 5. Well, you can see we've got it here. The difference between a number and 6. The difference between 6 and a number. Now, because subtraction is not commutable, these would generate two different numbers. One would be negative and one might be positive. All right, the product of 2 and a number. Product is multiplication. The quotient of a number and 4. Quotient is division. Quotient of 4 and a number. Whoa, sorry about that. 1/3 of a number. Or you could write this as x over 3. 1/2 of a number. Again, you could write it as x over 2. All right. Than. Now remember, move from right to left. So this one, when you see the word than, it's basically going to flip what we think of, right? 10 more than a number, we think of as that, but it really is x plus 10. 4 less than a number, you might think it is this, but it isn't. It's the number, and then you take away 4. So it's actually, so than flips them around. So you have to be careful of that. Subtracted from. Okay, same thing as a than. 7 subtracted from a number is going to be x minus 7. A number subtracted from 21 is 21 minus x. So, from is the other thing you have to be careful of. Now, here we have some combinations. 5 more than the product of 6 and a number. Okay, so we have 6, product of. Product of 6 and a number is 6x. 5 more than this means plus 5. Or you could do 5 plus 6x, that's perfectly fine. 4 times the difference of 8 and a number. So since I have the difference, I know this is what has to come first. The difference of 8 and a number. And then I have 4 times that, so I would put the 4 outside. 9 subtracted from, so that tells me it's going to be backwards. So I'm going to have a negative 9 here. The sum of a number and 1, so x plus 1. Okay? Translating consecutive integers. Consecutive integers means 2 in a row. So you're going to have, or integers that are directly following each other. So we'd have x, x plus 1, x plus 2. You could write them as x minus 1 and x minus 2. I hate negatives, so I would rather not do that. So I would stick to x plus 1 and x plus 2. All right, the sum of 2 consecutive integers. Well, here's my first one, and I have to add my second one. Now, you can put parentheses around this if you like to help you see that you actually have 2 numbers, x and x plus 1, that you're adding together. 3 consecutive integers, x. You do not have to put the parentheses, just so you know. Since it's all pluses, the parentheses won't matter. All right? Now, here we get to odd, and odd and even are going to have the same situation. My first one would be x, but in order for the next one to be odd, if x is odd, then I have to add 2. So that's actually 2 consecutive odd integers. If I want 3 consecutive odd, it would be x, x plus 2, x plus 4. Okay? Now, even you do the exact same thing. It's when you complete the equation that you'll find it'll come out even or odd. All right, consecutive integers. It's the sum of 3 consecutive odd integers. So again, x plus 2, plus x plus 4. And we just keep going up by even numbers, by 2s, 2, 4, 6, 8. The sum of 3 consecutive even integers. Now this is going to look exactly the same. The first one, the second even integer, the third even integer. The sum of 4 consecutive even integers. I'm going to do this without all the parentheses. I'm tired of writing parentheses. Now notice you could simplify this into 1, 2, 3, 4 x's, 2, and 4 and 6 is 10 and 2 is 12. Okay. Equal words or phrases. Is, was, will be results in the same as 5 is, so we're getting more into sentences. 5 is 2 more than a number. Notice the than, so we're going to do x plus 2. The product of 4 times a number is 16. 6 times the difference of a number and 4 is 12. All right, more practice. Translate the English phrase as an algebraic expression. The product of 7 and a number increased by 4. 13 less than, again I have a than, 4 times the number. So 4 times the number and then 13 less than that. All right, let x represent the number. Use the given conditions to write an equation and then solve it. So the quotient, division of a number, and 42. Increased by 7 is 13. All right, so I'm going to subtract the 7. I'm going to have x over 42 equals 13 minus 7 is 6. Now I multiply both sides by 42 to isolate the x. That's going to give me x equals 6 times 42, 240 plus 12, 240, 252. And there we go. All right, 4 times a number added to 7 times a number is 44. So I put these together and I get 11x equals 44. I divide both sides by 11, that's a 4, and I get x equals 4. When 3 times a number is subtracted from, which means 7 times the number comes first, subtracted from 3 times a number, the result is 44. Okay, I do this, I have 4x. All right, I have 4x equals 44. Divide by both sides by 4, I get x is 11. All right, an introduction to problem solving. Read the problem carefully, attempt to state the problem in your own words, and state what the problem is looking for. Okay, if necessary, write expressions for any other unknown quantities in the problem in terms of x. Write an equation in x that describes the conditions of the problem, solve the equation, answer the problem's question. Check the solution in the original wording of the problem to see if you've gotten it correct. Okay, now, a couple of other things that they don't go over in this first part. The question always gives you what your variable is going to be. Find each person's salary. So the salary, each person's salary is represented by x. The president of a certain university makes 3 times as much money, so that's my x, money. Okay, 3 times as much, so that's the president, as one of the department heads. So x is the department head. So department. If the total of their salaries, so the 3x plus the x, is 180,000, find each person's salary. Well, that means this is 4x equals 180,000. Divide by 4. Let's see, half of 18 is 9. Half of that is 4.5. So that's going to be 45,000. Okay, so this is the department head. So now we have to answer it according to what the question is asking. Find both salaries. Okay, so we have the department head makes that 45,000. And the president is going to make 3 times that. So that's 135,000. All right. A car rental agency charges $180 per week plus 0.25 miles to rent a car. How many miles? How many miles? So this is my x, right? Can you travel in 1 week for $3.95? So the cost is going to be $180 per week plus 25 cents a mile, which is my x. If the cost is $395, how many miles can you travel? So we're going to subtract 180 from both sides. And we're going to get, let's see, 280, 380. So 215 is equal to 25x. Divide both sides by 0.25. And x is going to equal, gotta get my calculator out. This one isn't quite so obvious. Divided by 0.25, sorry. 860 miles. And that was the question. How many miles can they travel in 1 week? The answer, 860 miles. Oh. Okay, this other one we forgot to box our answer. Whoa! Wow, that went all over the place. I don't know how that happened. Okay, moving on to number 3. The sum of the page number on facing pages of a book. So that's going to be x and x plus 1 are the page numbers. So now we're looking at the sum of the page numbers. X plus 1 is 525. Well, we're going to subtract the 1, put the two x's together. Cut that in half because we're going to divide it by 2. Okay, so 5, so it's 250 plus 12, 262. So we have the first page is number 262. The second page is number 263. There we go. All right. A rectangular field is 5 times as long as it is wide. So, if you need a picture, draw a picture. 5 times as long as it is wide. If the perimeter, which is this distance all the way around, is 288 yards, what are the field's dimensions? So that means I have x plus x and 2 5x's. And that's going to equal 288. So I've got 10, 11, 12 x's. So I divide each side by 12. And I put that in my calculator. 288 divided by 12. X is 24. Wants the field's dimensions. It's going to be 24 by, well, we want 5 times 24 is the other side, right? So that's going to be 120. 24 by 120. Doesn't, oh, it does say yards, so we probably should put the yards in there. The height of a bookcase is 3 feet longer than the length of the shelf. So if I have a bookcase here with shelves, the shelf is x wide, the height is going to be x plus 3. The bookcase has 3 shelves, not including the top of the thing, so I gave it way too many shelves. So we're going to take out that shelf, and we're going to take out that shelf. There we go. All right, so we've got 3 shelves, not including the top of the bookcase. If 18 feet of lumber is available for the entire bookcase, find the length and height of the bookcase. All right, so how much do we have to get out of this? We have to get x plus 3 twice. We have to get x for the very bottom of the bookcase, 1 shelf, 2 shelves, 3 shelves, and the top. So I need 5 x for all the horizontal surfaces. So I have to add that all together. So I have 5x plus x plus 3 plus x plus 3. So I've got 5, 6, 7 x's and plus 6. 18 feet of lumber. Wow, that's going to be incredibly narrow. I'm going to subtract 6, so 7x equals 17. 18 divided by 7. Sorry, that's going to be minus 6, so that's 12. I divide both sides by 7. X equals 12 sevenths, which is just under 2 feet. Right? Because, okay, no, so far we're all in feet. So this is 12 sevenths feet. Yes, so that's just under 2 feet is our X. So find the length and height of the bookcase. Yeah. Okay, we're just going to leave it as a fraction. So our width is 12 sevenths by, and then we have this plus 3. So 3 times 7 is 21. So I'm going to have 21 sevenths. 12 and 21 is 33. Okay. After a 30% reduction, you purchased a jacket for $98. What was the jacket's price before the reduction? So that's my X. So what I'm saying is $98 is the easiest way to do this is to say 70% of 98 because we've been doing these. Now the reason I know it's 70 is because it's a reduction, so it's 100% minus 30%, which is 70%. Okay, so the reduction, you're actually paying 70% of the price. So 98 is 70% of, not 98, of the original price. So I divide both sides by 0.7. And I get 140. That's the answer to my question. $140, because 98 is 70% of that. Okay, another way to look at it is to use that 30%. You'd say 30% is what? 98. Nope, that's really the only way you can do it. All right, a woman's salary was increased by 30%. All right, so increased by 30, so it's really 130% of what it used to be. Oh, this is giving me not the first number, but the last number. So, yes, so 27,300 is 130% of what? Okay, so 27,300 equals 1.3 times x. Divide both sides by 1.3. $27,300 divided by 1.3 is 2,100. So her original salary was 21,000. Okay, and we are done. All right, we'll see you in class.